In this video, we're going to look at 3 questions involving 3D trigonometry. The PDF to these 3 questions can be found in the description below. Try these questions and then use this video to help if you get stuck. The skills that you need to have to solve these questions are the basic sine, cosine, and tangent functions, as well as the Pythagorean theorem, which I have a video on if you want to check it out. First question, we can see that it is a cuboid and it asks us for the length of CF. To solve these questions backwards would be easier because then you know exactly what you need to arrive at your answer. Firstly, we're going to look at the triangle made by ACF that runs diagonally in the prism. You have the length of AC, which is 10 centimeters. CF is what is asked, and I'm going to label it with a question mark, and the missing piece of the puzzle is AF. To find AF, we can make another triangle ABF, that runs on the base of the prism. BF we have, which is 25 centimeters, and we have the angle BAF, which is 30 degrees. To include AF's length in our calculations, we can use the basic sine function, because we have the angle and the opposite side of the angle and the hypotenuse, or AF, and AF will be our unknown. Plug your values into the equation. To isolate AF, you can say AF equals 25 divided by sine 30. Sine 30 is equal to a half, or 0.5. Then 25 divided by a half is 50. Thus, AF is 50 centimeters. Going back to our initial triangle, we have two sides of the right-angled triangle, so we can use the Pythagorean theorem to solve for CF. CF squared is equal to AC squared plus AF squared. Plug your values into this equation. To get rid of the exponent of CF, we need to take the square root of both sides. This will cancel out CF's exponent. If you type the square root of 10 squared plus 50 squared, you will arrive at your answer. The length of CF is 50.99 centimeters if you round it off to 2 decimals. Question 2 features a square-based triangular prism with the side of the base being 5 centimeters. If you take a look at the shape, you can see that the triangle's angles are 60 degrees, which means that all 4 of the triangles are equilateral. Let's work our way backwards, starting from the final triangle EFS. S being the point in the middle of B and C, so that ES is the slanted height. Because EF is perpendicular to the base ABCD, the distance of FS will be half of 5 centimeters, which is 2.5 centimeters. EF is the length that we want in our final answer, and we can see that ES, the slanted height, is missing. So let's find it. Our next triangle that we'll work on is the triangle BCE, the right-hand side of the prism. The length of BC is already known, which is 5 centimeters, and the value for all of the angles are 60 degrees. When you divide BCE into 2 to work with the slanted height, the side BC is cut in half. So BS and SC will be half of 5, which is 2.5 centimeters. Because you have the angle and an adjacent side, BS, you want to find the opposite side, which is ES. Then you can use the tangent function, which is equal to the opposite side over the adjacent side. You could have used Pythagoras as well because the triangles are equilateral. Plug in your values into this formula. To isolate ES, we need to times both sides by 2.5 to get rid of the denominator. If you type 2.5 multiplied by tan 60 into your calculator, you'll get 5 square root 3 over 2 centimeters, which rounds off to 4.33 centimeters. We are going to use 5 square root 3 over 2 in our following calculations to make our answer more accurate. Now, we have the length of ES, the slanted height, and the length of FS is already known. We can use Pythagoras to calculate EF. We can use Pythagoras because it is a right angle triangle. That's important to know. So the hypotenuse ES squared is equal to the sum of FS squared and EF squared. Plug your values into this equation. Subtract 2.5 squared from both sides to isolate the EF squared. Then take the square root of both sides to cancel out EF's exponent. 5 square root 3 over 2 all squared is 75 over 4, and 2.5 squared is 25 over 4. Type square root 75 over 4 minus 25 over 4 into your calculator, and you will get your answer of 5 square root 2 over 2 centimeters, or round it off to 2 decimals, 3.54 centimeters. Question 3. Question 3 is a box where all the sides are known. 20 centimeters by 12 centimeters by 7 centimeters. There is a rod labeled AI that is inside the box, with GI being the length sticking out. We need to find this length of GI that sticks out, and we also need to find the angle that the rod makes to the base of the box, ABCD. It is given that the length of the rod AI is 50 centimeters, so we can say that the total length of the rod can also be expressed as AG plus GI. When we plug the value of AI in, which is 50, and subtract AG from both sides, we get GI equals 50 minus AG. Now we know that we need to find the length of AG. To find AG, we need to look at the triangle ACG. GC being, which is already known, 7 centimeters, and AG being our length needed for the answer. To get AG, we need to find AC. Let's find AC by looking at triangle ABC. We have 2 side lengths of this right angle triangle, so we can use Pythagoras to find the length of AC. The Pythagorean theorem states that the hypotenuse squared is equal to the sum of the other 2 sides, each one squared 2. That gives us AC squared equals AB squared plus BC squared. Plug in your values, which is 20 and 12. 20 squared is 400 and 12 squared is 144. To isolate the AC on the left-hand side, we need to take the square root of both sides to cancel out AC's exponent. Plugging the square root of 400 plus 144 into your calculator, and it should give you 4 square root 34, which rounds off to 23.32 centimeters. We're going to use the 4 square root 34 in the following calculations to make our answer more precise. Now that we have AC, we can go back to the final triangle. Because it is a right angle triangle and we have 2 side lengths, AC and CG, we can use Pythagoras to calculate the hypotenuse AG. The Pythagorean theorem states that AG squared is equal to the sum of AC squared and CG squared. Plug your values into your calculator, AC being 4 square root 34 and CG being 7. 4 square root 34 squared is 544 and 7 squared is 49. Yet again, isolate AG by taking the square root of both sides, and you get your answer for AG, which is the square root of 593, which rounds off to 24.35 centimeters. Now that we have the length of AG, we can calculate the length of the rod sticking out. Plug your values into your equation that we made earlier, and you will get the answer that is rounded off to 25.65 centimeters. To calculate the angle that the rod makes to the base of the box, we can use the same triangle ACG. Because we have all 3 lengths of this right angle triangle, we can use the sine, cosine, or tangent functions. I'm going to use the sine function. The opposite side of angle X is 7, and the hypotenuse is the square root of 593. If the angle is the unknown variable, press Shift-Sin on your calculator and put your fraction into the function like so. This will swap out the angle and the fraction. Your value for x will then be 16.71 degrees, rounded off to 2 decimals. And there we go. Thank you for watching, and I hope you've gained a bit more confidence with 3D trigonometric questions. Good luck on your math journey.